In this lesson, we're going to go over the distance formula, so you'll be able to learn how to find the distance between 2 points on a line. So the distance formula will help tell you the distance between 2 points on a line. So if I started maybe with this point here, and I wanted to find the distance to this other point here, we could use this formula to figure out the distance. So what we would do is we would label our points. Remember, in the coordinate plane, all points have the ordered pair x, comma, y. But in our distance formula, we have 2 points. We have this first point and the second point. So it would be kind of confusing to label them both as xy, comma, xy, because then which point are you talking about? So what we do is we use this little subscript that you see in this example here. We call this first point x1, comma, y1. These are just subscripts. It's just telling me that this is my first point. And in the second point down here, we're using a subscript of a 2, just so that we know that this is the second point, x2, comma, y2. So the subscripts are just telling you which ordered pair you're looking at. x1, y1 means I'm looking at this first ordered pair up here. x2, y2 means I'm looking at this one down here. It's just a way to differentiate between the 2 points. So if I want to find the distance between those 2 points, I'm going to use this formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So basically what we're going to be doing is we're going to be plugging in the values that we have for x2 and x1, and then we'll square that result after we subtract it. And then we'll plug in our value for y2 and y1, and then we'll simplify that as well. So we're going to basically be taking the ordered pairs and plugging them into the distance formula. So let's look at an example. So here is a graph. Make sure you sketch it. And we want to find the length of this line. So what we're going to need to do is we're going to need to find our ordered pairs. So if we look, there's one ordered pair is going to be here. So this is 1 point on the graph. This is an endpoint. This has the ordered pair 0. My x value is 0 and my y value is -5. And then this one up here has is the ordered pair 5, comma 1. So here I've identified my 2 points. I have 5, comma 1 and 0, comma -5. So if we remember, ordered pairs are x, comma y. So I have x, comma y and x, comma y. But remember, we need to differentiate between the 2 points. So this first point, I'll call it x1, y1. And the second point, I'll call it x2, y2. Just remember, we're trying to differentiate between these 2 points. So we're trying to figure out the distance between those 2 points. So we need to label one of them x1, y1 and the other one x2, y2. The next thing we're going to do is we're going to plug it into the distance formula. So distance, remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, we're just going to plug in our values that we have. So for my distance formula, square root of, well, what was x2? So if I look at my ordering up here, here's my x2. My x2 is 0. So I'm going to plug in, so making sure to include the parentheses, 0 minus, and what's my x1 value? So here's x1. X1 is 5. So 0 minus 5 squared. Plus parentheses y2. Well, what was y2? Here's y2. Y2 is -5. So -5 minus y1. What's y1? Y1 here is 1. And then that whole result has to get squared. So we will square it like that. Now we're going to simplify. So what we'll do is we'll do what's inside the parentheses first. So we'll do 0 minus 5 is negative 5 squared plus negative 5 minus 1 is negative 6. And then we're going to square it, so squared. So we did our operation that was inside the parentheses first. Now you can go ahead and square each of these numbers. So negative 5 squared means to do negative 5 times negative 5. That is positive 25. And if you weren't sure, you could double check on the calculator. In the second one, negative 6 squared means to do negative 6 times negative 6, which is 36. So we'll just add these together. So this is the square root of 61. And this would be the exact answer. If they asked for an approximation, you could just plug it into the calculator. You would go to your calculator, type 61, and click square root, and it'll give you about 7.8. So if they want it exact, then this first one is fine. If they ask for an approximation, the second one is fine. Example 2, find the distance in between each set of points. So this is exactly what we did in example 1, except now we're not given the graph, we're just given the two ordered pairs. So you're going to start off the same way. You're going to label one of them x1, y1, and remember that subscript 1 is just telling me that this is the first ordered pair. Then x2, comma y2. And again, that's just telling me that this is my second ordered pair. Labeling those are now going to help you use the distance formula. So the distance formula says that the distance between the 2 points is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Now we'll just plug in our values. So the distance is the square root of x2. So here's my x2 value. It's 2. So I'm going to plug in 2 for x2. Minus, here's x1. It's 3. So 2 minus 3 squared plus. And then y2 is 9. So I'm going to do 9. Minus y1 is 7. And then I'm going to square that. So now we've plugged in our values for x1, x2, y1, and y2. And now we will simplify. So we'll do 2 minus 3 is negative 1. So this will be negative 1 squared. So doing what's inside the parentheses first. Plus 9 minus 7, again, do what's inside the parentheses first. That's 2. Squared. And then we'll simplify that. So negative 1 squared means to do negative 1 times negative 1. That's just positive 1. 2 squared means to do 2 times 2, so that's 4. So my distance is the square root of 5. That's the exact answer. If they wanted the approximation, the distance would be approximately 2.2. So for example, this is actually example 3, but I want you to try this one on your own. So we have negative 6 comma 11 and 4 comma negative 1. So start off by labeling one point as x1, y1, and then the other point x2, y2, and then plug those values into your distance formula. So give this a try, pause the video. When you unpause it, I'll have a solution here for you. So hopefully you gave this one a try. In number 2 here, when you label your points, the first point I have negative 6 comma 11 labeled as x1, y1, and the second one I have labeled as x2, y2, it's 4 comma negative 1. Then I just plug those into my distance formula. So the first one I got 4 minus negative 6 plus negative 1 minus 11. Now, when we simplify the inside here, underneath the square root, when we simplify inside the parentheses here, 4 minus the negative 6, remember those negatives become positive. So a double negative makes it positive. So I'll do 4 plus 6, that gets me 10. And then negative 1 minus 11 is negative 12. And then just simplify this up. So this is 10 squared is 100, negative 12 squared is 144. So if you add those together, you get the square root of 244. That would be the exact answer. An approximate answer would be about 15.6. So part 3, does it matter the order in which we subtract the x values or y values in the distance formula, why or why not? So the answer here is no, the order does not matter. And the reason why the order does not matter is because we square x2 minus x1. We square this result. Remember, we raise it to the power of 2. And we square y2 minus y1. So we do y2 minus y1 squared. So when you square it, it takes care of the negative answer that you would get in there. So this is why order doesn't matter. Part 4, the last part, is applying the distance formula. So for this problem, I'm going to explain the steps to you, and then I'll show you what it looks like worked out. So for this example, I want you to determine if PQ, so the length of PQ, that's what that line above PQ means, is congruent to the length of QR. Remember, the line above, this means it's asking you for a length. And this means, are they congruent? So that's the congruent symbol. So I labeled these 3 points for you. Point P is the ordered pair 4, negative 4. So you could plot that in the coordinate plane. Point Q is the ordered pair 1, negative 6. Again, you could plot that in the coordinate plane. And point R is the ordered pair negative 1, negative 3. So what we're going to do to determine if these are congruent, so if the lengths of each of these are congruent, the steps that we'll use to do this is step 1 for PQ. So for the length of PQ, we're going to find the distance between points P and Q. For the length of QR, we'll do this something very similar, but this time we're going to find the distance or the length between Q and R. So this time we'll be using points Q and R to find the distance. So we'll be finding the distance between P and Q, and then we'll find the distance between Q and R. Lastly, we're just going to compare our answers that we get for the first two. So if they're the same, it means that the lengths are congruent, means the lengths are the same. If the lengths aren't the same, then it means they're not congruent because the lengths are different. So let me go ahead to the next slide where I have actually already worked this problem out. So my first step I have labeled here in green is step 1. I'm finding the length of PQ. So what I did was for P, I just wrote down my ordered pair is 4, negative 4. And for Q, I wrote down the ordered pair was 1, negative 6. Then I labeled x1, y1, and x2, y2, and then copy down my distance formula there. The next thing that I did after I have the distance formula copied down, I just plugged in my values for x2 and x1. So that was 1 minus 4. And then I plugged in my values for y2 minus y1. So y2 was negative 6 and y1 was negative 4. Notice when you substitute in that negative 4, you have 2 negatives. Remember, 2 negatives become positive. So this would really be saying negative 6 plus 4. So just be careful with your negatives. Then I'll do negative 3 squared because 1 minus 4 gets me negative 3, plus negative 2 squared because negative 6 plus 4 is negative 2. So negative 3 squared, negative 3 times negative 3 is positive 9, and negative 2 squared means negative 2 times negative 2, which is positive 4. So my distance for the first one is the square root of 13. So the second step, I have it labeled here in blue, find the length of QR. So first, just like I did for the first one, I copied down my ordered pairs. So Q is 1, negative 6, and R is negative 1, negative 3. I labeled one of them x1, y1, and the other one x2, y2. Then I copied down my distance formula. And then I substituted my values in for x2 and x1. So when I did that, I got negative 1 minus 1 squared. And then I also did the same thing for my y2 minus y1. y2 is negative 3, y1 is negative 6, so I plug those in there. Notice in the y's, I also had, again, this double negative. So negative 3 minus negative 6. Remember, those double negatives become positives. So I simplify. -1 minus 1 is -2 squared. And then -3 plus 6 is +3. And I have to square that. So -2 squared, so I'm on the step here. -2 squared is +4. And 3 squared is 9. When I add 4 and 9, I get square root of 13. Notice, so the last step, notice that these are the same. They're both square root of 13. So we would say, yes, PQ is congruent to QR. So you should be able to complete the assignment in MathXL called using the distance formula.